All right, so in this warm-up, we're reviewing factoring trinomials. And the reason we're reviewing it, because we're actually going to take it a step further in this next lesson. We're going to use it to solve quadratics. It's one of our ways of solving. So you needed to set up an x, have a times c at the top, b at the bottom. And that gives you factor 1 and factor 2. That has to satisfy both the product and the sum. On the second one, it's the same idea. We have the a times c, the b, factor 1, factor 2. The difference is you have to go back and divide by a because a is greater than 1. So now if we go ahead and look at the answers to these two. The first one, a times c is negative 18, b is positive 3. To get a negative product and a positive sum, I have to have one positive factor and one negative factor. So 6 times 3 is 18. If the 3 is negative, that gives me negative 18, and 6 plus negative 3 would be positive 3. So my factors are x plus 6 and x minus 3. On the second one, 5x squared plus 17x plus 6. My a times c is 30, b is 17. So I needed two factors that multiplied together to make 30 and added up to 17. Everything in this one was positive, so all my factors were going to be positive. So I found 15 times 2 multiplies together to be 30 and adds up to 17. But then I had to go back in and divide by that 5 because a was greater than 1. So 15 divided by 5 is 3. I couldn't reduce 2 over 5. So x plus 3 and x plus 2/5. But then the last step there is we take that denominator and move it over as our coefficient. So x plus 3 times 5x plus 2. That we should already know how to do. Today what's going to happen is we're going to set these trinomials equal to something so that we can actually solve them and come up with those values. In exercise 12.4, you guys found where your graph crossed the x-axis by graphing. You graphed it, you saw the points where it crossed the x-axis, and that was the solutions to that quadratic is where it crossed the x-axis. Now we're using factoring to do that same thing. So in your book there, it talks about, we've already worked on factoring quadratics or factoring trinomials. Now we're going to solve them, and we're going to solve them by using the zero product property. And the zero product property is down here at the bottom. For any real numbers a and b, if a times b equals 0, then a equals 0 or b equals 0. So for example, if x plus 3 times x plus 2 equals 0, then I can split it out to x plus 3 equals 0 and x plus 2 equals 0. So those factors we were just finding, we're going to be able to set those equal to 0 to solve and find where does this graph cross the x-axis. We're going to be able to find those points. All right, so we have a teacher-only problem here, so pens and pencils down. What are the solutions of the equation 4t plus 1 times t minus 2 equals 0? Well, I don't have to factor this. It's already factored, so what I get to do if they're already giving it to me in factored form is just split it out. So I have 4t plus 1 equals 0 and t minus 2 equals 0. Again, that's the zero product property that says I can split those out to both equal 0. Now it's just solving. Subtract 1 from both sides here. So 4t equals negative 1. Divide both sides by 4. So t equals negative 1/4. And then if I add 2 to both sides here, t equals 2. So there's my two values, my two solutions to these equations. Let's go ahead and take a look at yours in the book. What are the solutions of each equation? They've got 4 of them here that we're going to go through. These are already factored, so we're not having to do that step yet. So x plus 1 times x minus 5 equals 0. So we can separate that out. X plus 1 equals 0. X minus 5 equals 0. So we're going to solve them independently of each other. Subtract 1 from both sides there. So x equals negative 1. Add 5 to both sides. X equals 5. So if they're already in factored form and they already are set equal to 0, I can just put each parentheses equal to 0. The quantity 2x plus 3 times x minus 4 equals 0. So 2x plus 3 equals 0. X minus 4 equals 0. Subtract 3 from both sides. So 2x equals negative 3. Divide both sides by 2. So x equals negative 3/2. And because that can't be reduced, we can leave our answer like that. You don't have to turn it into a decimal. You could turn it into a mixed number, but you can just leave it as an improper fraction as long as it's been reduced down. And then x minus 4 equals 0. I'm going to add 4 to both sides. And x equals 4. C, we have 2y plus 1 times the quantity y plus 14 equals 0. So 2y plus 1 equals 0. Y plus 14 equals 0. Subtract 1 from both sides. 2y equals negative 1. Divide both sides by 2. Y equals negative 1/2. And then we have the other side, y plus 14 equals 0. Subtract the 14 from both sides. Y equals negative 14. And then D, the quantity 7n minus 2 times the quantity 5n minus 4 equals 0. So 7n minus 2 equals 0. 5n minus 4 equals 0. Add 2 to both sides. 7n equals 2. Divide both sides by 7. So n equals 2/7. Add 4 to both sides. 5n equals 4. Divide both sides by 5. N equals 4/5. So again, when they're already factored and set equal to 0, I just have to take each part, set it equal to 0, and solve. On the next page, you guys should have questions 1 and 2 that I want you to go ahead and complete in your group, and I'll pause while you do that. All right, let's go ahead and take a look at the answers to these. So number 1, negative 3n times the quantity 2n minus 5. Again, we could really put parentheses around that negative 3n and make it its own quantity. So we would do negative 3n equals 0, and then 2n minus 5 equals 0. The opposite of multiplying is divide, so I divide both sides by negative 3 to get the n equals 0. And then with 2n minus 5, I add 5 to both sides, then divide by 2, so n equals 5/2. So it's just simply taking each part and setting them equal to 0 to find those solutions. For number 2, we break out the 4a minus 7 and the 3a plus 8. So our answers are a equals 7/4 and a equals negative 8/3. Those would be the two solutions. But that's when we are given it already factored. Obviously, we're going to move another step to actually doing the factoring first and then solving the problem. So here I have a teacher only. So we're putting pens and pencils down. What are the solutions of the equation x squared plus 8x plus 15 equals 0? Well, I need to factor that first. So I'm going to draw my x. Here my a is 1, b is 8, c is 15. So 1 times 15 is 15, b is 8. So I need two factors that multiply together to make 15 and add up to 8. Well, this one's one of the easier ones because there's only two ways to make 15. It's either 1 times 15 or 3 times 5. So I know that one factor is a positive 3. One factor is a positive 5. So what this gives me is 8 plus 3 times 8 plus 5 equals 0, because remember up in the original problem there, it was equal to 0. So now x plus 3 equals 0, x plus 5 equals 0. Subtract 3 from both sides here. X equals negative 3. Subtract 5 from both sides here. X equals negative 5. So what are the solutions? Would be a, negative 5, and negative 3. So again, we're going to have to do the factoring first and then the solving. Let's go ahead and look at some problems in your book. What are the solutions of the equation m squared minus 5m minus 14 equals 0? So I'm going to draw my x. A is 1, B is negative 5, C is negative 14. 1 times negative 14 is negative 14. B is negative 5. So I need two numbers that multiply to give me a negative 14 and add up to negative 5, which means that one factor is negative and one factor is positive. Again, 14, there's only two ways to make 14. 1 times 14 or 2 times 7. Well, if 14 is negative and 1 is positive, that still only gets me to negative 13. If 7 is negative and 2 is positive, that gets me to negative 5. So negative 7 and positive 2. So I have m minus 7 times m plus 2 equals 0. I've now found my factors. So m minus 7 equals 0. M plus 2 equals 0. Add 7 to both sides. M equals 7. Subtract 2 from both sides. M equals negative 2. Okay, we've got more to do together. Here's B and C. So here A equals 1, B equals 1, C equals negative 20. So I need two numbers that multiply together to get negative 20 and add up to 1. So that would be a positive 5 and a negative 4. So P plus 5 times P minus 4 equals 0. P plus 5 equals 0. P minus 4 equals 0. Subtract 5 from both sides. P equals negative 5. Add 4 to both sides. P equals 4. Now, example C here. They're giving us an A value that's greater than 1, so we're going to have an extra step here. So I draw my X. A is 2, B is negative 15, C is 18. So 2 times 18, 36. And I needed to add up to negative 15. This is where you might have to go through your multiples, and to get a negative sum and a positive product. How can I get a positive product and a negative sum? 2 negative. So both factors are going to have to be negative. So negative 1 times negative 36 gives me positive 36. But negative 1 plus negative 36 gives me negative 37. Negative 2 times negative 18 gets me positive 36. But negative 2 plus negative 18 is negative 20. Negative 3 times negative 12 gives me positive 36. Negative 3 plus negative 12 is negative 15. There's my factors. That satisfies both the sum and the product. So I have a negative 3 and a negative 12. But then A is greater than 1. So I have to go back in and divide. Negative 3/2, there's nothing I can do there. Negative 12 over 2 becomes negative 6. So I have A minus 3/2 times A minus 6 equals 0. But again, that denominator is really going to come out front. So I have 2A minus 3 times A minus 6 equals 0. Now I can finally separate them out to solve each one using my zero product property. So 2A minus 3 equals 0. A minus 6 equals 0. Add 3 to both sides. 2A equals 3. Divide both sides by 2. A equals 3/2. Add 6 to both sides. A equals 6. So now we're combining what we learned about factoring, and now we're using that to solve. So it's giving us another method of solving. And I believe we still have 2 more to do together, or was that it? Oh, we're to your question 3 and 4. All right. So now, at the top of the next page, you guys need to complete questions 3 and 4. All right, let's go ahead and look at the answers to 3 and 4. Number 3, you needed a product of negative 32 and a sum of positive 4, which gave you a positive 8 and a negative 4 if you had to go through. If it didn't come to you right away, if it did, great. So you have G plus 8 times G minus 4. So you end up with G equals negative 8 and G equals 4. And then number 4, you had a value where A was greater than 1. So to get your negative 42 and your positive 1, you had to have a positive 7 and a negative 6. And then A was greater than 1, so we had to go in and divide by that 3. So it gave us 3Q plus 7 times Q minus 2. So Q is negative 7/3. And Q is positive 2.